Okay, welcome to Maths. Now, I have you guys homework, right? So we're going to look at that first. Okay, just to confirm, you guys can hear me, right? Just one person, please confirm that you can hear me.
Yes, sir.
Yeah, I can hear you.
Okay, thanks so much. Like when you're starting a lesson, I would have told, but I know you guys would have told me like we can't hear you, so it's okay, it's good. Okay, let's go. I'm going to share my PowerPoint slide. Okay, so this is where we kind of started on Monday. So I'm just going to rush through it. I did one example, I know, and I gave you two examples to do. So we're going to look at the one example I gave you and the other two one example we did together and the two examples I gave you. Okay, so if you look, right, you can see this is the graphs that I explained about. These are the formulas for volume moment that I told you guys about. I'm only thinking now that I should have sent a PDF of these formulas. I didn't even look for it. I've been so busy. My apologies. I'll try and do it maybe sometime as you're doing the lesson. I'll try and look for them. Okay. And then this is example one that we started and we did last week. They gave us this question here. They wanted us to sketch the graph of y is equals to 2 ln x. So you can see just from this example one that you need to know how to do ln. Okay, you need to know how to do graphs for log, exponent, trig, hyperbola, center hyperbola, rectangular hyperbola, semicircle, all these graphs. You need to know how to do them. By this time, N6, you should really be good at graphs. Okay. Basically, graphs start from, I think, as far back as N3, N4. No, so everyone would have started at N4 at least. You'd have done graphs. So let's look at this. So we sketch the graph. Y is equals to 2 ln x over 2. And then the volume when it rotates about the y-axis. This is what part that we did. Okay, so we know that if the limits are in the y-axis, the formula that we use is there. Okay, you can see the formula there. V is pi x squared delta y. If the limits are in the y-axis, it is also rotating about the y-axis. Okay, limits are in the y, it's rotating about the y-axis. That's what you use. Okay, because remember for volume, two factors, where are the limits, where is it rotating? So you can see from the formula there that at the bottom, the last line, we have 4 pi integral of e to the power y. Then if I integrate that, I get my answer for volume. Okay, next. Volume moment about the x-axis. So this is the formula for volume moment. Okay, you can see that it's, let me just write something. Okay, so this is my R and this is my dV here. Okay, so you guys, you remember when I was telling you that volume moment in the formula should just give you R dV. Then I explained for volume moment how we get the R and the dV is the volume. So the R, for in this case, it's y, because we're looking for volume moment about the x-axis. So our r is y. So that's what we do for this case. Okay, and from there, pi is a constant, so we can take it out of the integral. Then we just remove the y x squared. Okay, now the y stays there. Okay, because we're integrating with respect to y, so the y x stays there. And then the x squared, we put 2e to the power y over x. Then when we simplify, we get that last statement there. Now, how do you integrate y times e to the power y? I told you last week, right? Integration by parts. Because there are two different functions, so we can use integration by parts. So this is what we did, and then we got our answer there. Okay, so if you look at that integration by parts, the key part was to know that volume moment is r dv. Okay, and then you need to know what is your dv. Your dv is basically your volume. Okay. So yes, this is volume moment for example one we did. Okay, you can look at the working. As I said, I just use integration by parts because there are two different functions and you have to use integration by parts. Next. Remember, this is just a revision of what we did last week. That's why I'm going a bit fast. And then now to calculate the center of gravity, it's volume moment divided volume. Okay, so you can see that my volume moment is there, my volume is there. If I divide, I get my answer 2.157. Okay, so that is basically example one. Now we're going to go to example number two. After we do example number two, if there's any questions you can ask. Okay, remember what I said on Monday, that if you got some questions from some past papers that maybe you're doing on what you're trying out on what you're doing, you can tell me here. I'll not use PowerPoint. I'll actually use Word to do them right, to just show you how to do it. So if you have any questions, you can show me. You can let me know. I tried this past paper. I was struggling here or there, and then maybe I'll just help you out, guys. So that's basically it. Now let's look at example 2, the one I gave you as homework. 2.1, calculate the coordinates of the points of intersection of the graphs of y is equals to 4x minus x squared and y is equals to x. So I have two graphs, y is equals to 4x minus x squared and y is equals to x. So what do we do? The first part is to, okay, I'm just admitting someone. The first part, we need to calculate points of intersection. We have to sketch the graphs and then the area bounded by the graphs. 2.2, calculate the volume when this area is rotated about the x-axis. And 2.3, calculate the distance of center of gravity. So if they ask us for center of gravity, it means we have to calculate volume moment first. Okay, now you see, before I even start, just an idea. If you look at 4x minus x squared, I should know that it's parabola. Okay, because it's got an x squared and an x, so it's a parabola. And then y is equals to x, it's a straight line that passes the origin. Okay, just need to have those rough idea. Now we're going through the so this is how we find point of intersection. I told you that this is 2 marks. Okay, you have to do this working, all the working, but they only give you two ticks for that. Okay, it should be basic. I mean, points of intersection, you got two graphs. You want to find points of intersection, it should be straightforward. You can see from what I did there. I took y from the left and y from the right, the values of y on the left, this value of y on the left, I put it there, and then I took this value of y on the right, I put it there. Then I just solved. It's important now, when I solved, I got x is 0 or x is 3. I had to substitute into the y to get my y value. So my point of intersection is got x and y. Okay, that's important as well. So this is the point of intersection. Check what you did, see if there's any mistake or something. If it's correct, tick, just mark your work. Okay. Next, I'm sketching the two graphs. So you can see the first graph is y is equals to x, and the second graph y is equal to 4x minus x squared. It's a parabola. Okay, now here I didn't show it, but many times you have to show that this is y1 at the top and this is y2 at the bottom. Like that. You need to show that most of the time, almost all the time, in fact. So just give me, you need to show that all the time. Okay, there's a question from Spanelu Musa. You can ask.
So just to confirm, to get the point of intersection, we always equate the two equations, yeah?
I didn't hear you.
Just to get the point of intersection, just to confirm, we always have to equate the two equations, right?
Okay, I get you. Okay, now, Musa, okay, I hope you don't mind if I call you Musa, right? Just short. Musa is asking if do you always have to equate the two equations when calculating point of intersection? Not necessarily. Okay, there's an example we did. I'm not sure if it's done on Monday or last week Friday. There's an example we did where it was easier to substitute one equation into another, not to equate the two. Okay, let me see if it's the first example. Let me just see what the first example was saying. Okay. First example is one graph. Oh yeah, okay. First example is one graph. So it was the other question from last week Friday. It was not this Monday, it was last week Friday. What we did is we took the y value from the second equation and we put it into the first equation. So we didn't equate the two. Okay, so you don't always equate the two. But if you look at the example number 2, just for point of reference, why is easier to do that for example number 2? Because left side I have y equals to something, and then the other graph is also y equals something. When it's like that, it's easy to equate the two. But sometimes you might get a different setup, a different kind of questions. I'm just trying to think of the example we did last week, which had a different thing. Maybe I'll show you after the lesson. I'll open the slide from last week, then I'll show you. Okay. I hope that's okay, Musa.
I appreciate it, sir. Thanks.
Okay. Now, let's go on. So I've showed you guys. I've showed you guys this part. Now let's go to the next. So this is the sketch. All right. Now we're calculating volume. Okay. Now calculating volume, this is what we do. Sorry. Okay, I'm just showed you all the lines together. We use our formula pi y1 squared minus y2 squared. Then we integrate. I put my y1 and I put my y2. Then I square them. I remove the brackets. Okay, so just look at this quickly. If you're doing this, you're in the right track. Maybe you've made a mistake somewhere, you have to do the corrections. Okay. I answered it already twice about which graph do we start with, which one is y1, which one is y2. So I hope you were paying attention and you got to understand that. Okay, I remember someone asked on Monday, and I also explained it last week as well, to know how you choose y1, y2. Okay, I'm willing to explain for the third time if anyone wants to ask, but I hope not. Okay,
Yes,
so
sir.
guys,
Please explain it again, sir.
sorry?
Please explain it again, because
Okay,
I
I'll
wasn't here.
explain. Okay, I think you're not around. Yeah, remember, welcome. I didn't see you last week, that's why. What I said was, the graph, sorry, the top graph is always y1 and the bottom y2. Okay, I think I'll just explain it that way. I won't go into more detail, but the top graph, I prefer it to be y1 and the bottom to be y2. Okay, it's more easy that way. So your formula always starts with y1 squared minus y2 squared if it's volume. Okay, I hope that's clear. Kutwano.
Yes, sir.
Sir,
Yes, Chelsea.
so it will always be the top graph that will be Y1.
Sorry.
So it will always be the top graph that will be Y1.
Yes. Just make the top graph y1 and then let your formula. If your formula is volume, it will start with y1 squared minus y2 squared. If you're calculating area, it's just y1 minus y2. So you see, just make your top graph y1 and then your formula, let's start with y1.
Okay, so it will always be Y1 on the top and then Y2 on the bottom.
Yes. And then if you guys can see, right, if it's on the y-axis, if my limits are on the y-axis, it will be x1 is on the right and x2 is on the left. Okay.
Okay, that makes sense.
Okay. Okay, Darren, I think he was asking to present. I think he made a mistake. Darren Garvey. You're asking to present. I'm not sure why. So calculating volume, I showed you guys this. This is what we do to calculate volume. Okay, from here we're going to integrate that last line. If we integrate it, this is what we get. That's our answer there. So this is volume. It should be basic, right? It's pi y1 squared minus y2 squared. You put your y1, you put your y2, you expand because they are squared. After you expand, you simplify and then you integrate. Okay, that's the first part, right? For volume moment, I think that should be 2.2, calculating volume, right? 2.1 was point of intersection and sketching the graphs, showing the area and the representative strip. That was 2.1. 2.2 is now calculating volume. We have done that. Sorry, I'm just trying to put my phone on mute. Okay. Now, 2.3 is, okay, I hope I can move on to 2.3, right? But you guys should be marking, you should have done this already, just marking, so, or taking a picture, the very minimum. Okay, 2.3 is like this. Oh no, sorry, yeah, 2.3 volume moment. This is what we'll do. If you look at it, let me show you. it's R times dV. Okay, now what is my R? Here I'm looking for volume moment about the y-axis. So if it's volume moment about the y-axis, my R is X. And then my dV is pi bracket y1 squared minus y2 squared. See, now from here, that's how you get this part here. Okay, so I should have added these lines, but I didn't add them, right? So your volume moment is R times dV, and since it's volume moment about the y-axis, our R is going to be X. Then dV is pi y1 squared minus y2 squared. Okay, I should have put a dx here, right? Like this, because it's with respect to X, because our limits are in the X. Okay, so we do all this. Now, if you look at it, what you should do, if I can just go through it, let me just change my color. Let me use purple. What you should do is, when you put the formula on this step, simplify what is inside the big bracket, like simplify y1 squared minus y2 squared here. What is inside the bracket here? You simplify that first before you multiply the X. Okay, just makes it more easy for you. Simplify, then you multiply the X. So I'm going to go to the next slide, right? Just to show you what final answer we have for volume moment. But this is how the steps that you do. Okay, just wait a few seconds before I go.
Sir.
Yes.
So you say like the basic steps for when doing like volume moments, it's just to basically write down substitute your equations into like obviously y1 y2 squared, and then take your squared and like expand it, and then integrate from there.
Come again, Chelsea. Sorry.
So I'm asking.
Are you asking for volume moment? Is it the volume moment part?
Yeah, I'm asking about volume moment. So I want to know like the basic steps that we will basically be following for majority of the these volume moments, is that we have to substitute our equations for our lines into y1 and y2, and then after that, then we expand it, and then we'll like obviously integrate it. Is that how
That's
I would do
correct.
it?
That's correct.
Okay. Okay, sir.
Okay. So next step is the next step now is to complete. Now you do the integration, and then you get your answer. So this is your answer volume moment. You have substituted, like what Chelsea was just asking now, is basic. You just substitute. When you substitute your values, you integrate, then you get your answer. Okay. And then if you're looking for center of gravity, it will be volume moment divide volume. Okay, so when we get the integration, we get our answer 729 over 20 pi. I prefer to leave my answers in terms of pi most of the time. I just think it's more neat. That's me. I don't like to do the rounding off thing. But it doesn't matter however you do it. They'll be having both answers. So after we find volume moment, okay, let me just leave this just a few seconds for you to look at it. After we find volume moment, we need to just say center of gravity is volume moment divide volume. Like this. Okay, any question on number 2? Even if I want me to go back a slide or 2, I can go back. Any question on number 2? Anything you're not sure of before we go to number 3?
Could you please go back to the previous slide?
Okay, I'll go back to the previous slide. Okay, yeah, there you go.
Thank you, done.
Okay.
Okay.
Chelsea?
So then your the way you get your answer, would you have gotten that 3 from your point of intersection?
Yes, that's correct.
Okay, so then you would just obviously substitute that into your x values to get your answer.
Yes.
Okay, no, that's fine. Thank you, sir.
Just confirm the answers when do it by yourself and confirm, because you know I like sometimes when I'm typing the PowerPoint slides, you know, I'll be focusing more on the PowerPoint than the actual maths. So once in a blue moon, I make a mistake. I make some few mistakes when I'm typing. Like last week, I think Monday or so, somebody showed me some bit of errors in the actual calculation. Okay, but I don't focus on that a lot. You know, I'm focusing more on the method. So you guys get to know the method. Mistakes, I make mistakes. So maybe you might make mistakes, but you have to make them as lead to. That's why I always tell my students, double check your work. You can't 3-hour paper, you can't finish in 3 hours. I even told you guys for Medicine 5 last semester. A 3-hour paper you can't finish in 3 hours. It means you don't understand the subject yet. You gotta finish it in 2 hours, 30 minutes, 2 hours, 40 minutes at most. You can't go beyond 2 hours, 40 minutes. Finish early and then double check your work, go through it and double check so that you are 100%. Usually sometimes it's the questions that are easy to you that you relax a bit, because maybe it's a topic that is easy to you, relax a bit, you might make a mistake. And think about it, the easy ones, one that you're supposed to actually pass, but you might make a mistake, and department are not really forgiving on that. Okay, so we're done here with example 2. This is the last part, right? Let's go to example 3 and see. This is example number 3. All right, now, this is one graph. Okay, I should have maybe picked one for 2 graphs, but it doesn't matter. We're still learning anyways. Sketch the graph of y is equal to tan x. Show the strip perpendicular to the x. So they tell us here where the strip is supposed to be. Perpendicular to the x-axis, meaning it's facing the x-axis. Then calculate the volume generated when the area bounded by the graphs, the ordinates y is 0 and x is pi over 4 rotates about the y-axis. Okay, then 3.2, calculate by means of integration the volume. 3.3, calculate the volume moment as well as the distance of center of gravity. So, first part is the sketching and the representative strip and the area, all that. This is where it is. You can see my sketch for y is equal to tan x.
Yes, sir.
Thanks. And then you can see where my area is. They told me between y is 0 and x is pi over 4. So that's my area there. And then you can see my representative strip is there as well. So I've answered that first part. Okay, let me just see how many marks it is. Okay, it doesn't show. Usually it's about 2 marks, which is 4 ticks. So how do they give you 4 ticks? They give you 1 tick for the graph, 1 tick for the shaded area, 1 tick for the representative strip, and then usually 1 tick for the limits. Okay, that's how they do it. Next, we're calculating volume. Okay, now this is the formula for volume. And then y squared, you put y is tan, so it will be tan squared. If you integrate tan squared, that's what you get. Okay, now you need to know, guys, integral of sine squared, cos squared, tan squared, cot squared, it's in the formula sheet. Okay, you need to always know where it is. So if you integrate tan squared, that's what you get there. And then if you put, let me just keep it there a bit longer.
Sorry, sir. Sorry, sir.
Yes, Daniel.
Yeah, can I see the previous slide for the graph?
The slide for the graph.
Yeah.
Okay.
Thank you, sir. Thank you.
Okay. And then this is the next part for volume. It's not complete. The next slide will show the completed answer for volume. Now, to complete the answer here, what we get for volume. So this is just volume. I think someone. Okay, so next we're going to go to volume moment.
Sorry, sir.
Yes.
Can you please go to the next slide?
Next slide.
Yes.
The next one.
The previous. Sorry, the previous.
Previous. Okay.
Yes. Okay. Okay, thank you, sir.
Okay. Now, next, guys, after volume, we have.
Sir.
Yes.
Sir.
Yes.
How did you arrive at 0.214 pi?
Okay. This is
When I.
is this Sipe or Kutwano who's asking?
Oh, okay. My mistake. I forgot something. So I forgot that pi in trigonometry is 180. My bad.
Oh, yes. Thanks so much. And I was supposed to remind everyone about that. Pi, if it's inside the trig, it's 180.
But it still gives me 0, sir.
It gives you?
When I press it in the calculator, it still gives me 0.
180 over 4. What is 180 over 4? It's 45. So what is tan 45?
Let me see.
1.
Remember, when you're punching, you see this should be on its own. You punch tan 45. You punch tan 45, and then pi over 4, you punch it as it is. You don't say 1 minus, then you punch pi over 4.
Oh,
Like
okay.
this.
So thank you.
Yeah, that's how you
Thank
punch
you.
it. Like that. Okay. Okay.
Sorry, sir.
Yes, I'm listening.
Yeah. Can I see the original graph? That one we have to integrate.
You want
Maybe
to see
I'm
the
having some
original?
confusion. Yeah, the one
What,
will have to integrate.
what do you want to see?
Maybe I'm having some confusion, so I don't remember if it is tan square or
The original question.
the original graph that will have the original graph that will have to integrate.
This one, yeah.
Yeah. So Angit, the graph is y equals to tan x. That is
Yeah, that's correct. Y is tan x.
so when we integrate it, it doesn't give us the ln of sec.
No, remember it's y squared. It's not y, so it's tan squared.
Yeah. Oh, so
If you look at
on the formula sheet here, the tan squared.
What is the formula? What is the integral for tan squared on the formula sheet?
The formula sheet gives us 1 over a tan ax minus x.
That's correct. But what is your a? Here your a is 1. You see, a is the coefficient of x. In this case, it's what? It's a 1 here.
All right, I see, sir. Thank you.
Okay. Okay. Spare, are you answered? Are you good?
Yes, sir.
Okay. Now just checking with spare. Okay, let's go on to the next part. What time is it? Oh, okay, we're still on time. Good. We do this to get our answer and then volume moment. Now, this is volume moment. Okay, just look at the steps, right? And see if you get it. Remember, this is my R here. Okay, let me use a red pen. This is my R here. Then I have my DV here. Okay, so just look at it, guys, a few seconds. If Now, guys, if you look at here, the last step, okay, because the other steps, I think they are straightforward. If you look at the last step, you have x times tan squared. So how do you integrate that? You use integration by parts. Your x will be your u, and tan squared will be your v prime. Okay, so that's what we're going to use. Okay, so take note of that. Remember that integration by parts is got the formula and all the like. So I'm going to go to the next slide, which shows the formula. Okay, so just look at that.
Sir, just to double check, this is integration by parts, right?
Yes, integration by parts.
Okay, thank you.
Okay, guys. From here, you finish up and then you get the answer. Okay, I hope you guys it finished the previous slide. I can always go back again, but it's integration by parts. Many times I would even, if it was possible, I would like just to show you x tan squared, then I go straight to the answer 0.13 pi, because I would want you to practice integration by parts, but it's fine. I've showed you all the working there, but I know you guys should be practicing it by yourself as well. Okay. Any questions? This is volume moment. Now, after volume moment, to find center of gravity, it's volume moment divide volume. Okay. Now, as you can see, guys, I'm not explaining these slides. Why? Because it is integration by parts. So if I can just go back, let me just go back. This is the formula for integration by parts. Okay. Then I put my values. I told you that u is what? X. U is X. V prime is tan squared. So if you have u and v prime, you need to calculate u prime. U prime is 1. And then v is equals to, you integrate from v prime to v, you are integrating to be tan x minus x. If you integrate tan squared, you get tan x minus x. So you can see this is my v, this is my u prime here. This is my v, and this is my u. Okay, so you can see it's just basic integration by parts, which I strongly feel you need to know it. You have to know it like by now, as easy as that. Okay, because it's part of module 2, it was done in N5 as well. Then you complete, because here 1 times here, this part is just tan x minus x, because the 1 multiplies everything inside. So if 1 multiplies tan x is tan x, 1 multiplies x is x. So if you integrate, tan is ln sec. If you integrate, x is x squared over 2. Important thing is you have to put it inside a bracket, this bracket. If you don't put it inside this bracket, you get a wrong answer. Okay. Then you remove the bracket on that last step. Okay, so I'm just saying this is integration that I'm explaining, right? Integration by parts. I'm just explaining to you. I'm thinking you should be knowing it, but I'm just explaining step by step. But as I've told you guys, you can always ask anything if you're not sure. Then we get our answer 0.13 pi. And then from there, we find our volume moment. Okay, so this is module 2. If you want me to go back any slide, please tell me. If you have got any questions, tell me as well. I'll leave it on the last slide for example 2.
Question: how much marks is this whole section as the whole question?
Okay, that's a good question, Musa. That's a good question. That's a good question, Musa. What happens is this. Okay, I'll show you for example 3, right? So that you have an idea of it. Then I'll explain about the marks. Okay. Okay, guys. Was that example number 3? Oh, I thought it was example number 2. My apologies. Let's go to the question so that I can answer Musa's question. In fact, I know a better way. Let me quickly get a past exam paper. Just give me a minute. I'll get a past exam paper, then I'll show you guys Musa's question. I'll try and get a paper as recent as possible. 2019, let's see, November. Okay, I got a past paper. Okay, I'm going to just remove my PowerPoint. And then I'm going to share my PDF document. Where are you, PDF document? There you go. Okay, can you guys see this past exam paper?
Yes, sir.
Yes, sir. Mute.
Not here, sir.
Mute.
Yeah.
Okay, now
Yeah.
let's go to, why am I seeing? Now, sorry, I just need to mute. Now, if look at this, right? This paper, you see, question 5 got 40 marks. The section we're doing module 5, so 40 marks. And it comes with 4 questions, right? What happens with 4 questions? One of the questions, it's called the section on depth of center of pressure.
Yeah.
Yes?
Do you mind zooming it? I cannot see anything.
Yeah, let me zoom it. I wanted to, because the questions are on different pages, so I wanted to show them together, but let me zoom it, it's fine. Okay, is that better?
Yes, it is.
Okay, cool. It is now, so if you look at it, usually it's about 10 marks each section, like 5.1, 10, 5.2, 10, 5.3, 10. That's how they give the marks. Okay, so look at 5.1. It gives you, says calculate points of intersection, sketch the graphs. That's 3. Now 3, if you remember well, 3 means 6 marks. Okay. Now I can even tell you the 6 marks on this question 5.1.1. Where do they give you the 6 marks? They'll give you 2 marks for calculating points of intersection. They'll give you 2 marks for each of the graph, 1 mark for each of the graph. Then they'll give you 1 mark to show the representative strip and 1 mark to show the enclosed area. Okay, because look at the question, it says calculate points of intersection. They want you to calculate that, they'll give you marks. Sketch the graphs, they'll give you marks. Show the area, they'll give you marks. Show the representative strip, they'll give you marks. So you already know how they give you marks. Okay, so it's 3 here, but it's actually 6 ticks. Then 5.1.2, calculate the area. Again, all the steps to calculate the area, you do that. And then calculate the moment of area. That is centroid. Remember, we did that, I think, last week when we were calculating first moment of area. Okay, so we did that as well. I even gave you an example on that, and we calculated. This is like 6 marks, which is like 12 ticks, because it's quite a bit long. Okay, so this is 5.1. Now, the one we are doing is 5.2. I'm just going to show it because it's got different pages. So if you look at 5.2, sketch the graph. Sketch the graph. And then this graph, it's what do you call it? You know, the rugby ball, oval, right?
Ellipse.
Ellipse, yeah, ellipse. It's an ellipse. Thank you. It's an ellipse. Okay, so you should be able to know if you look at what the names don't matter. Definitely names don't matter. What matters is you can sketch it. So you sketch that graph. That's 5.2.1. Now it's only 2 marks here because it's one graph. And you're not calculating any points of intersection. Okay, so if you sketch is 2 marks, which is 4 ticks. They'll give you two marks for the graph, 1 mark to show the area, and 1 mark to show the representative strip. From there, they will say 5.2.2, calculate the volume generated if it rotates about the x-axis. So volume is pi y squared dx. So you're going to make y squared subject to formula. Okay, so volume is pi y squared dx, then you do it. And then let's look at 5.2.3. Calculate the x coordinate of the x coordinate of the center of gravity. So if they want the x coordinate, first thing you calculate is the volume moment. Okay, you calculate volume moment. Then after volume moment, the x coordinate is just same as saying volume moment divide volume. Okay, so if you look at this is about 5.2 is about 10 marks. 5.1 was 12 marks, 5.2 is 10, 5.3 is how many? 10, then 5.4 is 8. And then it gives you 40 marks. So you should expect on question 5, 3 of the questions will be asking you for either area moment, volume moment, centroid, second moment area, or moment of inertia. The 3 questions on question 5. And then the fourth one, 5.4, it will ask you depth of center of pressure, which is a bit different to what we're doing. Okay. So guys, we are basically done, right? We're basically done for today's lesson. We did volume moment. This paper that I just, I'm just showing you, this is 2019 November, right? I put it on my class as well, and I even put the memo as well, but you can always email me or send a chat if you don't have it. I can send it to you. You try it and even send you the memo as well. Okay. So thank you so much, guys. Next week,
Imali lo mthetho semidlalo wamasha njalo ngabe yajwayela phela. Awuyajwayela yazi.
Let's imagine your mistake of it.
Hawu yazi zingibana. Kancane. Singing.
okay, apologies for that. I just got knocked out. I don't know what happened. Okay. Thank you so much, guys. Any questions before I go? Any questions anyone wants to ask before I go? No questions. So thank
Hello,
you,
sir.
guys. Yes.
Is the PowerPoint that you are presenting with on the portal as well, or is it just like
Sorry?
notes and past papers? That you're presenting with on the student portal as well as notes and all of that.
I asked if the question paper is on the portal.
No, the PowerPoint that you were presenting with just now.
Yes, they are on the portal. They are on the portal as well.
Okay, sir. Thanks.
You're welcome. Okay, thanks so much, guys. Have a good weekend. See you Monday.
Bye, sir.
Bye.